Hello everyone. Welcome to the SciEd School. Today, we will learn about STP and RSTP, Spanning Tree Protocol and Rapid Spanning Tree Protocol. We have learned about the STP in the previous chapter. Today, we will look into it in detail. STP process. STP elects one of the switches in the loop as the root switch. The other switches will be the non-root switches. All the non-root switches has one port that has the fastest way to reach the root switch. This port with the lowest cost or fastest way is called the root port. The other end of the root port link is the switch port with much lower cost to reach the root switch. This port is called designated port, DP. All the ports on the root switch are in forwarding state and are called designated ports, DP. Besides RP and DP, all the other ports in the switch loop are in blocking state to prevent the loop and are called blocked port, BP. We can see in this topology that the STP process has ended and a root switch has been selected. We can see that all the ports on switch 1 are the DP, designated ports. Switches 2 and 3 are the non-root switches. Switch 2 has selected one port with the lowest root cost as RP, root port. All the other ports on switch 2 are DP, designated ports. Switch 3 selects one port with the lowest root cost as RP, root port. However, to avoid the infinite loop and to block the redundant link, switch 3 makes its one port as BP, blocked port. BP could have been from switch 2, however, BP is decided based on the root cost. Hello BPDU and the bridge ID, BID. Hello BPDUs, bridge protocol data units, are packets sent by switches on a network to maintain the spanning tree protocol, STP. Hello BPDU has a bridge ID parameter to elect root switch. The bridge ID, BID, is a unique identifier for each switch in a network using spanning tree protocol, STP. It consists of two parts. Bridge priority, a 2-byte value that can be configured on the switch. Lower values have higher priority. MAC address, the unique MAC address of the switch. The bit is used to elect the root bridge, which is the central switch in the spanning tree. The switch with the lowest BID becomes the root bridge. If two switches have the same BID, the MAC address is used as a tiebreaker. We see in this topology that the STP election process starts and all the switches in the loop starts forwarding BPDUs with the bridge ID. Each switch claims to be the root switch at the beginning. However, when the switch finds out that the other switch BID has higher priority, it starts propagating it as a root switch in the BPDU, and at the end, a root switch is elected. No, we see that the switches 2 and 3 elects switch 1 as root switch. Switches 2 and 3 are non-root switches. Now, switches 2 and 3 selects root ports. Ports with lower root cost is selected as root port. In switch 2 gigabit interface G0/0 has the lowest root cost and becomes root port, RP. In switch 3, G0/0 has lowest root cost and becomes root port, RP. Port at the other end of the root port link becomes DP, designated port. Now, switches 2 and 3 needs to decide the blocking port to block the redundant link preventing the loop. At the end, switch 3 blocks its port connecting the switch 2, thereby blocking the redundant link. Switch 2 port could have been the blocked port, however, its root cost is less. After the election of the root switch and the forwarding blocking ports, the network becomes stable until the topology changes or a link fails. STP in stable state. Root switch creates and forwards hello BPDUs every 2 seconds. Every non-root switch forwards the same hello BPDUs modifying bridge ID and the root cost. What if these hello messages are stopped if a link fails? Switch wait for max age timer of 20 seconds, after which the switch acts reacting to change the STP topology. Blocked port will change its state from blocked to interim listening, 15 seconds forward delay, and from listening to interim learning, 15 seconds forward delay. Once the BP passes learning state, STP process starts again. Please keep it in mind that the network convergence will take 20 seconds, max age timer, plus 2 times 15 seconds forward delay totaling 50 seconds convergence time in STP. What happens in an interim listening and learning state of a port? These temporary STP states help prevent temporary loops. Listening. Like the blocking state, the interface does not forward frames. The switch removes MAC address table. This MAC table entries could be the cause of the temporary loops. Learning. Interfaces in this state still do not forward frames, but the switch begins to learn the MAC addresses of frames received on the interface. Why do we need RSTP, Rapid Spanning Tree Protocol? The reason is the convergence time. 50 seconds convergence is a huge delay in today's networking world where speed is the utmost priority. RSTP works in a similar fashion as STP with minor differences. However, the main thing is the quick convergence in RSTP. RSTP convergence time is few secs to max 10 seconds. STP and RSTP differences. Age timer. STP hello max age timer is 20 seconds whereas RSTP max age timer is 6 seconds. RSTP can communicate with the neighbors, if no hello message, to check if something happened in the network without waiting for timers. RSTP has a concept of alternate port which can take the position of root port immediately if the hello message stops. To be an alternate port, both the RP and the alternate port must receive hellos that identify the same root switch. As soon as the link fails, the alt port will become root port and the MAC address table will be flushed to prevent any temporary loops. We can see RSTP protocol applied in this topology. Switch 3 selects an alternate port so that it can become root port if the root port link fails. RSTP ports terminology. If the ports connect one switch to another, they are called point-to-point ports. If they connect end-user devices like server, they are called edge ports. STP and RSTP works in default configuration. If we buy a brand new switch and connect the switch in a loop, RSTP or STP will work without any configuration. However, network engineer might want some switch to be the root switch based on the topology and the need. Network engineer can change the priority of the switch using specific commands so that it always gets elected as the root switch. Do STP and RSTP creates unique topology per VLAN? Yes. STP and RSTP creates unique topology per VLAN to balance the load and use the block links. There are protocols which create per VLAN topologies like PVST+, per VLAN spanning tree, Rapid PVST+, Rapid per VLAN spanning tree. We can see a topology with VLAN 1 and VLAN 2. Rapid PVST+ protocol creates two separate paths for both the VLANs. VLAN 1 has a different root switch and VLAN 2 has a different root switch. And DPs and RPs differs in both the topologies. Here switch 1 is the root switch. Let's look at the VLAN 2 path. Here switch 2 is the root switch and switch 3 alternate and root ports changed. How Rapid PVST+ creates unique paths for VLAN and RSTP. This protocol modifies BID of the switch. It adds VLAN ID to the priority ID and it's done. PVST+ will decide different RP and DP per VLAN. We can change the priority per VLAN to change the root switch per VLAN using the global command. Spanning tree VLAN, ID, priority, number. We can decide which switch to be the root or secondary root by using the global command. Spanning tree VLAN, ID, root primary, secondary. Let's look at this topology in the spanning tree with just one native VLAN. Let's go to the switch 1 and check if it is the root port and the port status. We use the command show spanning tree in the enable mode to check the spanning tree status. We can see the root ID here, which is same as this switch bridge ID, which implies that this switch is the root switch. We can see that it is mentioned here that this is the root switch. We can see the address of the switch here. We can see the timers and the forward delay time. We can see the interface status here. As this is the root switch, all the ports are designated and the root cost is 0. Now, let's check a topology with two VLANs. This is a topology with two VLANs. Let's go to the non-root switch now and type the same command. Let's choose switch 2 in this case. Let's check the root ID and the bridge IDs. We can see that the address are different, which means that switch 2 is non-root switch. We see that the protocol used here is PVST, per VLAN spanning tree. We see two spanning trees detail here, VLAN 1 and VLAN 2 as PVST protocol is used. Now, let's see the port status. As switch 2 is non-root port, one of its port is RP, root port, and we have the root cost here per port as it is not the root switch. Similarly, we can analyze VLAN 2 spanning tree.